So compound interest using recursion is quite time consuming. So what if we wanted to do it without recursion? Thankfully, we have a formula for that, so we can do it. And this is a formula that many of you are probably familiar with. So AN equals P, open bracket, 1 plus I, close bracket, to the power of N. So what do these variables mean? So first, P is the principal, and that's the initial quantity. So if, for example, we had like $20,000 in a bank account, then that would be the principal. That's like our starting point. And then I is X divided by M, where X is the interest rate per annum, so again yearly, and then M is the number of compounds per year. And this is like what I highlighted before. I wanted to just quickly mention again that it's really important to notice, or to be very cautious about how we are actually defining our variables. Because again, it's not about what letters we use, because sometimes that changes from formula to formula, because here I has to be that value there, but I is actually equal to this, so we can't have I in the same position that it was last time. So it's really, really important not to trip up and make a mistake when you're defining your different variables and values. It's not important to memorize what I is, what X is, what M is, or if you do have consistent letters that you use for this in your own study or in the own rules that you use, then that's awesome. Keep running with that. But the most important thing, again, is to remember and define what it is we're actually doing. So here, we're saying that I is equal to the decimal interest rate per annum divided by the number of compounding periods, like how we defined R before. We're just talking about it a little bit differently. But when we defined R in a recursion, we said 1 plus the decimal interest rate per annum divided by the number of compounds per year. But here, we actually don't have a 1 plus, because that 1 is already built into the compound interest formula. So make sure you don't add another 1, or it'll end up being 2.0 something, and that would be quite a high rate of interest. So yes, make sure you take that into account. So yes, P, principal, our initial value, 1 plus the decimal rate of interest divided by the number of compound periods per year. So yeah, number of compounds per year, and then to the power of N, which is the total number of compounds. So say, for example, we had a loaner investment that was compounding monthly, so 12 times per year over a 3-year time period. That would mean N would be equal to 12 times 3, which is 36, because the total number of compounds in this loaner investment would be 36, because that means it's compounding 36 times, because it's compounding every single month for 3 years, which 36 months is how we get 36 compounds. So let's do a question to kind of illustrate a little bit further. So let's go back to our scenario where we had $1,000 as our initial value, and it was compounding monthly for 2 years, so 24 compounds total, at 6% per annum. Let's define our variables. So P, principal, initial starting value, was $1,000 that we had. And I, was defined as our decimal rate of interest per annum, which was 6%, so we get 0.06, because we take 6 and divide it by 100 to get our 0.06, and then we divide it by 12, because that's our number of compounds, so we can see that our I is 0.005, which is what we found. R was 1.005 in our previous question. And then, like I said, N is going to be 24, because it's compounding monthly over 2 years. And then we can substitute into our formula. So we've substituted in the value for P, the value for I, and the value for N. And then all we need to do is put that in our calculator and solve for it. And we can see that we actually got the same answer we got when we used recursion. This was just a much quicker process than having to apply the same rule 24 times over. Whereas here, we only had to fill in the one formula. So that is the beauty of the compound interest formula. So we're going to do a practice question now from one of the NEEP trial exams, which are really good resources if you're after some practice questions to do. So this one says, a person wishes to put $2,000 into a saving account and they want to receive $600 of interest. So we're being told different information this time, which is interesting. The interest rate we're told is 3.15% per annum, and we're told that we have monthly compounds. All really important information. So we're told to calculate the number of years and months it will take for the person to receive $600 of interest. So interesting, we've been given different variables this time. So we're still going to start with our same starting point. A equals P, 1 plus I to the power of N. But here, A is not our unknown. We actually know what they want A to be. They're going to put $2,000 in to begin with, and they want to receive $600 worth of interest. So their desired end goal amount for this investment is the initial amount plus how much they want to earn in interest. So the goal amount in this scenario is $2,600. We also know P, the principal, because we're told how much they're going to invest. So we know that the starting point is $2,000. And we can also calculate I. They've arranged their formula slightly differently here, but it's still the same effect as what we've been talking about. So what they've done is they've taken the interest rate per annum, which is 3.15%, and then think of it like they've divided it by 100, and they've also divided it by 12, which is the number of compounds per year. So they've done the exact same process. They've just set it out a little bit differently. So we've calculated I, and then that's what we know. So now we can substitute it into our formula. We know that A is $2,600. We know that P is 2,000. We know that in our brackets we'll have 1 plus the value for I. And then we'll also, that'll just leaves us with N as our unknown, which makes sense because the question is asking us to calculate the number of years and months it'll take for the person to receive $600 of interest. So the unknown is the time period. So that's the N. So that's what we're trying to find out. So what they've done to simplify this is they've divided each side by 2,000 so that we can isolate more of our variables. So we took 2,600 and divided it by 2,000. We divided this side by 2,000 as well, and that cancelled out. So we're left with 1 point, our I value to the power of N. And now to solve for N, we're actually going to use trial and error, which is a totally appropriate method to try and find the value of N, because otherwise we'd need to use like logarithms, and that gets really complicated, and we actually don't learn that in general math. So that's not actually a way that we need to use to solve the problem. So to use trial and error, we choose different values for N. We're going to say let N equal this, and we'll see if that works for our equation. So for example, what if we let N equal 5? Well, if we put this number to the power of 5, it would equal 1.0131, and the number would go on, but that's way, way lower than 1.3. So, and we know that's nowhere near equals to, so we know that that N value is going to be far too low. And then what if we said, we'll let N equal 200? That'd give us 1.68, which is way too high, so we know it's going to be less than 200. What if we try N equals 100? That'd give us 1.2997, which is really, really close to 1.3, but that means we still haven't hit 1.3, so that means we're still not at the right point. What if we let N equal 101? Then that would give us 1.3031, and it would go over, and then ... And that is just over the required value. So we know that N equals 101 will meet the requirements of the equation that we're looking at. So that means when the money, our initial quantity, has compounded 101 times, it will take, that is how long it will take them to reach the desired amount. And because we're talking about monthly compounds here, N equaling 101 means that it will take 101 months for them to reach $2,600. And we can actually convert that into months and years. So therefore, it will take 8 years and 5 months to receive $2,600, and that will give them their desired goal of that $600 of interest. So that's how I would approach a question such as this one. So it's important to note that we don't just need to use the compound interest formula for loans or investments where the amount is unknown. Like with any other formula, we can actually rearrange it and solve for other variables. So that's